And lastly today, this question. Okay, so we've got a satellite moving from left to right, so it's moving in a straight line. And we've got two rocket motors. Remember how these work is that, say this one here is throwing mass out that way, so it's pushing the mass that way. And so by Newton's third law, the mass is pushing back that way. So this motor is going to cause a forwards force, and this one is going to cause a backwards force. And I'm going to put numbers on just because I always think that makes it easier to think about. Okay, so the first part, describe the change in motions. That means what's happening to the speed, what's happening to the direction of the motion when both motors are fired. So that's this situation. Well, we can see that the resultant force on the satellite is 0, so the acceleration is 0. So that's going to be the first mark. There's no acceleration. It's going to keep going along its straight line at constant speed. However, we can see that these two forces form a couple. They may cancel out force-wise, but in terms of the moments they cause, those don't cancel out. They're both acting to turn the satellite clockwise. So for the second mark, the satellite will start to spin and then spin faster and faster in the clockwise direction. Okay, and now for the second part. What if only rocket motor A is fired? Now we can see that we do have a resultant force forwards. So for the first mark, the satellite is going to accelerate to the right. Okay, and now, if the resultant force on an object is 0, then you can take moments about anywhere you like. And if you get 0, then the object is not spinning. But if there is a resultant force on an object, then you can't do that. If there is a resultant force on the object, the point you have to choose is the centre of mass. Now, I'm just going to assume that our satellite is completely uniform and its centre of mass is the middle. So this force here, is it going to cause a moment about that point? Yes, it is. So for the second mark here, our satellite is also going to start spinning, or they would let you have it if you said it turns. It starts to turn there. So, but there is a resultant moment, and so it will start to spin. I'm not going to go into any more detail on that because I think it's possibly not the time. I might do a totally separate video on that distinction.